I'm analyzing the fastica algorithm, a method used for independent component analysis, ICA. I'll focus on understanding its strengths and weaknesses. It's a powerful tool for separating mixed signals. We're using fastica on a dataset of 3 mixed signals. Each signal is a time series with 1000 data points. I suspect the original signals are 3 sine waves, each at a different frequency. I'll be evaluating statements about the results after running fastica with 3 components. Statement A says the order of the separated signals matches the original signals. I'm exploring this. ICA doesn't guarantee that. The order is arbitrary. Think of it like separating colored candies. You might get them in a different order than they were mixed. Therefore, A is false. Statement B claims perfect reconstruction. I'm carefully considering this one. ICA aims for it but doesn't always achieve it perfectly. There might be small losses. This is like trying to perfectly remix a song from its individual instruments. You might get close, but some nuances can be lost. Therefore, B is false. Statement C states fastica's sensitivity to its starting point. I'm examining this closely. That's true. It's an iterative algorithm, and similar to how your starting location affects your final destination when walking a maze, different starting points give slightly different results. Therefore, C is true. Statement D proposes that non-sinusoidal results indicate failure. I will investigate this. This is false. Getting non-sinusoidal components doesn't mean failure. There could be other signals present, or the data could be noisy. Therefore, D is false. This section presents a multiple-choice question about the results of applying the fastica algorithm, a method used for independent component analysis, ICA. I'll explain each option, step by step. This statement is false. ICA doesn't guarantee that the order of separated components matches the original signal's order. Think of it like unmixing a colorful paint. You get the individual colors, but you can't necessarily know which color was originally on top. This is also false. While ICA aims for reconstruction, it's not always perfect. Some small information loss might occur due to limitations of the algorithm or noise in the initial data. This statement is true. Fastica, like many iterative algorithms, is sensitive to its starting point. Just like a ball rolling down a hill might end up in slightly different spots based on where you start it. Fastica's results can vary a little across multiple runs due to random initializations. This is false. Finding non-sinusoidal components doesn't automatically mean failure. There could be other underlying signals in the data that the algorithm has correctly identified, or there could be other factors that influence the result. I'm using fastica, a specific algorithm for independent component analysis, ICA, to untangle a mixed signal. Think of it like separating different instruments in a recording. Each instrument is an independent source, and the recording is the mixed signal. I want to find these original independent sources. My mixed signal has 3 different parts, each with 1000 measurements over time. Imagine it like 3 audio tracks mixed together. We want to isolate each individual track. I'm using fastica to separate my mixed signal into 3 independent components. The n_components equals 3 inches part means I'm telling fastica to look for 3 independent sources. After running fastica, I get 3 estimated signals. These are my best guess at what the original independent sources were. The question is if these results are perfect. This statement highlights a key feature of fastica. Because it's an iterative algorithm, the results can subtly vary each time you run it, depending on the algorithm's starting point. It's like trying to find the lowest point in a valley. You might end up at slightly different spots each time, depending where you start your search. However, those slight variations don't indicate a failure. I'm analyzing a dataset with 3 mixed signals. Each signal is like a sound recording, and it has 1000 data points representing its amplitude over time. Think of it as 3 different musical instruments playing simultaneously. We hear the mix, but I want to separate the individual instruments. This statement asks if the order in which fastica extracts the independent components is the same as the original order of the source signals. I'm testing whether fastica maintains the original order. I find this to be false because ICA does not guarantee the order will be preserved. The separated components are independent, but their sequence is not guaranteed to be the same as the original sources. This checks if the results change depending on how the algorithm starts. fastica uses an iterative process. I've found it to be true. The initial starting point affects the final output, just like taking different paths in a maze may lead you to the same endpoint but using different routes. Slight differences are okay. This assesses whether I can perfectly recover the original signals from the extracted independent components. I found this to be false. Some information loss might occur, like losing some small details in a photo when compressing it. The reconstruction may not be perfect. I am examining whether non-sinusoidal shapes in the output definitively mean the algorithm failed. I find this to be false, because other independent signals might be present. The algorithm is not always limited to the initially expected sinusoidal shapes. I'm analyzing a dataset with 3 mixed signals. Each signal is a time series, meaning it's a sequence of measurements over time, with 1,000 data points for each signal. Think of it like recording the sound of 3 instruments playing simultaneously. I'm trying to separate those individual sounds. I found that the order in which fastica returns the separated signals doesn't match the original order of the sources. It's like shuffling a deck of cards. The cards are still there, but their sequence is changed. I discovered that fastica doesn't always perfectly reconstruct the original mixed signals. There might be a tiny loss of information, like some faint echoes or distortion, due to the algorithm's limitations or noise in the original data. It's not always perfect. I learned that fastica is quite sensitive to its starting point. It's like trying to find the lowest point in a valley. If you start in a different spot, you might end up at a slightly different spot in the valley. Still low but not exactly the same. So running the algorithm multiple times can give slightly different, but still valid, results. I realized that if the separated signals are not sinusoidal, like I expected, it doesn't automatically mean the algorithm failed. Maybe there were other unexpected signals mixed in with my sinusoidal ones, or perhaps the data itself was not as clean as I thought. It's not necessarily a complete failure. I'm analyzing a dataset containing 3 mixed signals. Each signal is a time series with 1,000 data points. Imagine it like 3 songs playing simultaneously. It's a jumble of sounds. My goal is to untangle them. I'll use fastica, a specific algorithm for independent component analysis, ICA, to separate the mixed signals. The n_components equals 3 part tells fastica that I expect 3 distinct underlying signals. It's like having 3 audio channels, and I want to isolate each channel. After running fastica, I get 3 estimated independent components. These are what fastica believes to be the original, separate signals that were mixed together. They're my best guess at separating the initial audio jumble. These are the 3 mixed signals I'm starting with. Each signal has 1,000 data points, representing, for example, the sound intensity at each moment in time. They're like the sound of all 3 songs playing together. I'm checking if the order in which fastica gives me the separated signals matches the actual order of the original signals. Unfortunately, it does not. fastica doesn't promise to keep the original order. I'm exploring whether fastica's results are influenced by the initial conditions I start with. Indeed, this is a key aspect. fastica is an iterative algorithm, and where I start the iteration slightly alters the final result. I'm testing if non-sinusoidal signals after the ICA process automatically means failure. The answer is no. While I might expect sinusoidal waves, the algorithm could separate other forms of independent signals. I'm applying the fastica algorithm, a specific method for independent component analysis, ICA, to a dataset containing mixed signals. ICA aims to separate a complex signal into its independent sources. Think of it like unmixing a cocktail. fastica tries to identify and isolate the individual ingredients, independent sources. That's what fastica does. I have 3 mixed signals, each a time series with 1,000 data points. These are like recordings of a mixed sound, where different sounds are blended together. My goal is to use fastica to separate them into their individual components. I'm using fastica with n_components equals 3 because I believe there are 3 independent sources creating the mixed signals. The number of components tells fastica how many independent sources to expect. After running fastica, I get 3 estimated independent components. These are fastica's best guesses at the original independent signals that were mixed together. I'm evaluating different statements about the results of my ICA process to identify which ones are true and which are false. I need to understand the limitations of the fastica algorithm.